Hello teachers and students. You are welcome to NK Sir's Organic Chemistry classes. Today we are going to discuss about the stability of charges. Now generally guys, I think you know a neutral atom is always more stable than charged. So guys, neutral is more stable than charged. For example, I am taking here O and here I am taking O minus. Which is more stable? Yes, O is more stable than O minus because it is neutral. But when all charged species are given, how to know which is more stable? In that case, we have to depend on two factors. What are the two factors? If the elements are belonging to same period, then depend on electronegativity. So guys, if the elements are belonging to same period, our deciding factor is what? Electronegativity. But how to depend? Negative charge is more stable on more electronegative atom. So once again you see, negative charge is more stable on more electronegative atom. Next, if the elements are belonging to same group, then depend on size. So guys, if the elements are belonging to same group, our deciding factor is what? Size. And as we know, in a group, size increases from top to bottom. So positive or negative charge is more stable on large atoms. So once again, I want to summarize these two factors. When elements are belonging to same period, depend on electronegativity. When elements are belonging to same group, then depend on size. Now we are going to do some questions based on this concept. So arrange the following in their stability order. Now you see positive charge on carbon, nitrogen, oxygen and fluorine. So you know these elements are belonging to same period. So when they are belonging to same period, what is our deciding factor? Electronegativity. And how to depend? Negative charge is more stable on more electronegative atom. Here who is more electronegative? Fluorine. Fluorine is more electronegative, but it is having a positive charge. So do positive charge more stable on fluorine or on carbon? Yes, positive charge is more stable on carbon. Therefore, this is the stability order. Great guys. Now let us move to the second question. Now you see negative charge on carbon, nitrogen, oxygen and fluorine. Again, they are belonging to same period. So again, our factor is what? Electronegativity. Then according to our factor, negative charge is more stable on more electronegative atom. So negative charge is more stable on fluorine because it is more electronegative. Therefore, what is the stability order? Negative charge on fluorine greater than oxygen, greater than nitrogen, greater than carbon. I hope you are able to understand this one. Then, now let us see the next question here. So here, sulfur negative charge, chlorine negative charge. Again, they are belonging to same period. So depend on electronegativity. And I think you know, halogens are more electronegative. Therefore, negative charge is more stable on chlorine. Then, let us move to the next one guys. Negative charge on fluorine, chlorine, bromine, iodine. So now they are belonging to same group. So when they are belonging to same group, we have to depend on what? Size. And I think you know, negative or positive charge is more stable on large atoms. So negative charge is more stable in iodine than bromine, than chlorine, than fluorine. I think it is clear to everyone. Now let us move to the next one. Now here you see positive charge on fluorine, chlorine, bromine, iodine. So again they are belonging to same group. Again depend on size. So where positive charge is more stable? Positive charge is more stable on iodine than bromine, than chlorine, than fluorine. I hope this concept is clear to you all. Now next question you see now. Now here you see positive charge on carbon, here also carbon and here also carbon. When charge is on same atom, then depend on hybridization. So here you see now this carbon is sp2 hybridized, this carbon is also sp2 and this carbon is sp. If you are confused to find hybridization, I made a video on hybridization. So please look into my channel about the hybridization video. Now here you see positive charge is present in vacant pure p orbital, whereas here positive charge is present in sp2 hybrid orbital, and here positive charge is present in sp hybrid orbital. So from here to here and here to here, percentage of S character is increasing. So when percentage of S character is increasing, then electronegativity also increases because they are directly proportional. So this is more electronegative, which one? Sp. So more electronegative is having positive charge. Therefore, what is the stability order of the positive charge? Yes, it is 1 greater than 2 greater than 3. Now, let us go to the next question. Negative charge on carbon here also and here also. So, when the negative charge is on same atom, as I told you in the previous question, depend on hybridization. What is hybridization here? sp3, and here sp2, whereas here sp. So here, as I mentioned already, that percentage of S character directly proportional to electronegativity. So electronegativity is more for sp, and negative charge is more stable on more electronegative sp carbon. So negative charge is more stable on sp carbon than sp2 than sp3. Now here the most important point is more electronegative atoms can bear positive charge when its octet is completed. Now for example, you see this one, who is more electronegative? Oxygen, obviously. So it can bear the positive charge. Why? Why? Because its octet is completed. If you see clearly, 8 electrons are there around oxygen. And in the first one you see positive charge on carbon, and in the second one positive charge on oxygen. So now can you tell me where positive charge is more stable? Positive charge is more stable in second one, though positive charge is there on more electronegative oxygen. Why? Why? Because its octet is completed. So guys, did you understand one important point here? When electronegativity and octet are in competition, then which is given priority? Octet is given priority. So this is the way that how to check the stability. Thank you one and all.